through of this week's problem set, which is, I'm sure you'll all be sad to know, the last problem set of this class. So as you know, the topic of this week was baking, and really the point of baking, besides trying to give you some sort of an intellectual framework to think about baked goods, was to show you that when thinking scientifically about baking, really many of the ideas of this class all come together and are necessary in order to understand how recipes work. And this week's problem set asks you to think through two different recipes to that end. So the equation of the week this week is basically the baking soda reaction, and that basically is to remind you that 1 mole of sodium bicarbonate, that is 1 mole of baking soda, produces 1 mole of carbon dioxide gas. And of course, it's the carbon dioxide gas that's produced that causes the puffing, and the rising of all different kinds of baked goods. And this equation, it's really a little bit of it's a different bit of chemistry than that which we've discussed so far, but it and its consequences in the recipes that we look at is really the heart of the matter. So there are two problems this week that you have to think about. The first is basically the one that we discussed in class, where we discussed this wonderful Coca-Cola cake, and we compared it as best we could to Joanne Chang's yellow birthday cake, which she discussed with us in class on Tuesday. And we basically have both recipes here, and if you sort of go through the thing, there are a number of questions that are asked, and basically the point is that the question go through the basic physical numbers that you need to think through to really be able to compare these two different cakes. And so the first thing that we do is we ask you to compute the pH of the batter, and we point out to you that, as Joanne really pointed out, that buttermilk is acidic, and the other two acidic ingredients in the Coca-Cola cake are Coca-Cola itself and cocoa powder. And we ask you basically to apply the ideas in basic chemistry and pH that we discussed in the first week of this class to compute the number of moles of protons that are contributed by the buttermilk, by the Coca-Cola, and then by the cocoa powder, which is the other acidic ingredient. Now, the reason that this is important, of course, is because the acid reacts with baking soda, which produces carbon dioxide gas. That was really the essence of the equation of the week, and this actually produces the leavening, which is question number 2. So we then basically ask you to take the baking soda, for which there's whatever amount there was, I think it was like a teaspoon, and ask how many moles of baking soda does that correspond to. And of course, if there's a mole of acid for every mole of baking soda, then that produces a mole of carbon dioxide gas. And we ask you to compare the two. This question here, number 2b, is a bit tricky. You need to think through the discussion that we had of this in class, because although you will find when you do it that the number of moles of the acid are much smaller than, or the number of moles of the protons in the acid are much smaller than the number of moles of the baking soda, you have to remember that once you deplete that acid, once those protons are used up in the reaction, more can be created. And so you should review the discussion that we had in class on that point. So then number C asks you to compute the number of moles of gas that are produced from the baking soda. Actually, this says from the baking powder. Now, for baking powder, you need to also go through the class discussion where we pointed out that baking powder is a combination of baking soda and tartaric acid. That tartaric acid has about twice the weight of baking soda, and so about a third of the mass of baking powder is actually baking soda, which is which is used in the reaction. And so you can compute the number of moles of CO2 that are produced from there. And then we get to we found the interesting part of this recipe, which is the carbon dioxide gas production. And there the point really is to figure out how much carbon dioxide was dissolved and compare that with the amount of baking soda. And finally, we just ask you to think about what happens when the temperature rises, what happens to the carbon dioxide, what the consequences of this are for the color of the cake. We then ask you to think through, really rather briefly, the viscosity and the elasticity of the batter by doing the sorts of things that we did in viscosity and elasticity week when we basically computed the mass fraction. And then we ask you similar questions about gluten and albumin, and these are questions that you might recall. This is very similar to the problems that we had during, I think, the 3rd week of the course when we were doing elasticity and we had a problem about pancakes. So finally, the second question that we gave you is on French country bread, and this isn't really so much a quantitative question, it's a qualitative question to ask you to think through the different aspects that we've discussed in the context of the bread recipe. So bread is different because actually instead of carbon dioxide gas being produced by baking soda and baking powder, it's produced by live microorganisms, namely yeast. And the yeast are put in a starter culture, and we first ask, what happens if you don't have the starter culture at all. We also ask you what happens if you don't have bread flour at home, which is what's called for in the recipe, and instead you have pastry flour, and what are the differences of that, how will substituting pastry flour for bread flour affect the final result. We ask you the consequences of leaving salt out. This is something that you would be well advised to go back and think about our discussion of the molecular interaction of gluten molecules when we discuss strudel dough. There's also somewhat of a discussion in the EDGE videos this week to discuss what happens there. And we ask you to think about what's going to happen if you don't have any kneading. What do you think will change if there isn't kneading? And finally, we ask you just to think a little bit and to describe a little bit more on a molecular level what's happening when the loaves rise before there's baking. That is, why do the loaves rise a little bit before you even bake them? And then finally, we ask why bread, when you bang on it, sounds a little bit hollow. The last thing for this week is to give an update report on your final project, and this is much the same type of report that you've been doing up until now. And the point here is really that we want to help you sort of brainstorm your final project and keep you on track. And so this is just a way to have feedback. Anyway, I hope you enjoy the last problem set.